Section 6.3, Finding Probabilities for the Normal Distribution. So to compute probabilities for a continuous random variable involves computing the area between the distribution curve and the axis. So once upon a time, this involved computing z-scores and using tables of normal areas. Fortunately, this is a statistics using technology textbook, and so we're going to learn how to use technology to compute these probabilities when we know that the random variable has a normal distribution. So the first technology that we're going to look at is for computing probabilities for normal random variables. And again, our main technology that we're going to be using here is going to be our calculator. So on the TI-84, we would push second variables to open up this distribution menu. And in here, the one that we're looking at for probabilities when we're dealing with a normal curve is normal CDF. So we would push 2 to pick normal CDF. And then we would either have a screen that looks like one of the following. So within your textbook pages, you should circle which one of these looks like your calculator and cross the other one off, because again, it just depends on if you have the older operating system, yours says normal CDF with an open parentheses and you have a blinking cursor. But if you have the newer operating system, it says normal CDF and then it actually lists the 4 things that it's waiting for you to give to it. So on the calculator, if we hit second and then variables, because above that is distribution in the same color as our second key, it opens up this distribution menu. And of those choices, we want normal CDF, so we would push button 2. Okay. My calculator, you can see, has the newer updated operating system. So in here, I'm going to enter the numbers that are shown on your textbook page there. So we're going to enter in 10. And then for the upper is 20, and then the mean of the distribution was given as 2, and standard deviation of 1. Okay. And so then we would hit paste, we would highlight that and hit enter. Okay, now it looks on screen like the other models of the calculator. So if your screen looked like the one on the left, you would have hit 10, 20, 2, 1, where the comma key is above your 7 key on your calculator. Okay, so once we're all to this point, we would hit enter, and it gives us a probability here. Okay, so now keep in mind the 6.28, a probability can't be 6.28 because it's greater than 1. So this e minus 16 at the end means times 10 to the negative 16th power. So this probability is really, 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 really small. All right, so this previous one, we were finding the probability of getting an x value between 10 and 20 for a distribution where the mean was 2 and the standard deviation was 1. But many cases, as we look at the distribution, where one of our endpoints might be infinity because the curve extends on the x-axis from negative infinity to positive infinity. So if we have an interval where the lower endpoint is negative infinity, we're going to use negative 10 to the 99th power for that. Okay, now that's not what negative infinity is equal to. Okay, negative infinity is not a number, it's just a symbol for as negative as we can go. So on the calculator, we're going to use negative 10 to the 99th power for that. Same with if the upper endpoint is infinity. Again, that also, there's no number equal to infinity, so for statistics, we're just going to enter 10 to the 99th. So these are close enough approximations for the infinities when we use them in statistics. And then we would highlight paste and push enter. Okay, so here where it says calculate, that's actually not what that says here. That would actually, so if you have the newer operating system, you would have to hit paste and hit enter, and then your screen looks like this one, and once we've got those in, we would hit enter again to get that final end result.